Do you live in Papua New Guinea, the Solomon Islands, Australia, or anywhere along the Western Pacific? Do you have family near Manus Island, Kaviengs, or Kimbe? If the answer is yes, you need to watch this full video because what just happened beneath the Bismarck Sea deserves your full attention. And what has been quietly building there since May is still not finished. On July 13th, 2026, at 8:53 in the morning UTC, the ground beneath the Bismarck Sea ruptured. The United States Geological Survey measured it at magnitude 6. 4. The European Seismology Agency EMSC recorded the exact same number. The quake was shallow, only about 10 kilometers down, which is exactly the kind of depth that makes people nervous, because shallow quakes shake harder at the surface, and shallow quakes near water are the ones tsunami centers watch the closest. Tens of thousands of people felt this one. Roughly 64,000 people experienced light shaking. Another 22,000 felt it as a weaker rumble that still made dishes rattle and still made people sit up in bed wondering what was happening. The epicenter sat about 192 kilometers southeast of Lorengau, a coastal town of under 6,000 people. It's at 263 kilometers from Kavieng, a town of almost 15,000. And it sat over 300 kilometers from Kimbe, home to nearly 19,000 more. These are not empty coordinates on a map. These are real towns, real families, real fishing boats tied up at real docks, and real people who went to bed that night not knowing the seafloor beneath them was about to move. Think about that for a second. 64,000 people is roughly the population of a mid-sized city, all feeling the ground move beneath them at almost the same moment, in a part of the world where many coastal homes are built from timber and tin roofing, structures that can handle a tropical storm but were never engineered with strong seismic codes in mind. When a shallow magnitude, 6. 4 hits, it is not the magnitude number that determines what breaks. It is the depth, the local soil conditions, and how close people are living to the epicenter. 10 kilometers down is shallow enough that the shaking arrives fast and sharp instead of slow and rolling, which is part of why so many people across such a wide radius felt it immediately. Here's the problem. This earthquake did not happen in isolation. It happened almost directly on top of something that has been erupting underwater, completely out of sight, for more than 2 months. Back on May 8th, 2026, seismometers across the region picked up a small swarm of earthquakes in the exact same stretch of the Bismarck Sea. Scientists did not think much of it at first. Small swarms happen. But within a day, satellites caught something no one expected. NASA's Aqua and Terra satellites photographed white, steam-rich plumes rising straight out of the open ocean, with nothing around them for miles. No island, no landmass, just the sea, venting steam into the sky like something underneath it had woken up. A separate NASA satellite called PACE, built specifically to track ocean color and plankton and aerosols, detected the water itself turning green and spreading outward in a widening plume, the unmistakable signature of chemical and mineral-rich material pouring up from below. This is where it becomes serious. Within days, the European Space Agency's Sentinel-2 satellite and NASA's Landsat-9 captured high-resolution images confirming it. Then, on May 12th, an instrument called VIRES, riding aboard the joint NASA and NOAA satellite SWOMI NPP, detected thermal anomalies covering nearly 3 square miles of ocean surface. Volcanologist Simon Karn, who studies exactly this kind of activity, said there had to be an enormous volume of hot material sitting close to the surface to generate a heat signature that large. Pumice, the light volcanic rock that floats, began forming rafts on the surface, drifting for miles on ocean currents, a floating trail of evidence pointing straight back to the source. That source has now been given a name. Scientists are calling it the Titan Ridge Volcano, sometimes referred to as the Central Bismarck Sea Volcano. It sits about 125 kilometers southeast of Manus Island, right on the northern edge of the South Bismarck tectonic plate, in a stretch of ocean floor so complex and so poorly mapped that researchers have compared it to knowing less about it than they know about the surface of the moon or the canyons of Mars. This region sits at the collision point of multiple tectonic forces at once. Faults, volcanic ridges, rift zones, subduction zones, back arc spreading centers. All of it crowded into one small stretch of seafloor and almost none of it properly surveyed before this year. But here is the part that should make you pay attention. This volcano has only been recorded erupting once before, back in 1972, and that eruption was minor and mostly forgotten. For over 50 years, this feature sat quiet and unmapped beneath hundreds of meters of water. Then, this year, without warning, it woke up. And it has not stopped since May. Most people watching a headline like this scroll past the geology without understanding just how strange it is for a volcano to be discovered mid-eruption. Modern volcanology usually works the other way around. Scientists identify a mountain, study its history, install monitoring equipment, and wait. Here there was no mountain to study. There was open ocean, over 1,000 feet of water in some nearby soundings, sitting above a feature that barely existed on any map until researchers from Guiomar Helmholtz Center for Ocean Research in Kiel, working with the University of Ottawa, published new bathymetric surveys in 2024, just 2 years before this eruption began. Large stretches of that seafloor remain only roughly mapped or completely unexplored even today. In other words, the volcano that is now erupting in front of orbiting satellites was essentially invisible to science until just before it woke up. Now the focus shifts to why an eruption like this matters so much, and why an earthquake, striking almost the same spot 2 months later, is not something scientists are willing to dismiss as coincidence. When magma systems beneath the seafloor are actively pressurizing, actively pushing molten rock upward, the surrounding crust becomes stressed. That stress has to go somewhere. Sometimes it releases as more eruptive activity. Sometimes it releases as earthquakes on nearby faults that were already under pressure from decades of slow tectonic movement and just needed one more push. A magnitude 6. 4. Earthquake, shallow, 10 kilometers deep, striking in the same active zone as a live underwater eruption, is exactly the kind of event that keeps volcanologists checking their monitors at 3 in the morning. And there is a reason the fear is not coming out of nowhere. This region has already shown the world what a submarine eruption can do. In January of 2022, the Hunga Tonga Ha'apai volcano, sitting underwater near Tonga, erupted with a force that stunned scientists around the planet. It sent a shockwave through the atmosphere that circled the entire Earth, not once, but multiple times, registering on barometers as far away as the United States and the United Kingdom. It triggered tsunami waves that struck Tonga directly, killing people, destroying homes, and cutting off the entire nation from outside communication for weeks. Those same tsunami waves crossed the Pacific and were measured as far away as Peru and the west coast of the Americas. It remains one of the most violent volcanic events ever captured by modern satellites. And it started the exact same way this one did. Quietly. Underwater. Barely noticed until it wasn't. One more thing you need to know about that 2022 event, because it is the exact comparison so many scientists keep coming back to. The Hunga Tonga eruption did not just produce a tsunami. It produced the largest atmospheric explosion recorded by modern instruments in over a century, releasing energy equivalent to many hundreds of Hiroshima-sized bombs in a matter of minutes. It punched water vapor and ash more than 50 kilometers into the atmosphere, into a layer of the sky most volcanic eruptions never reach. It triggered sonic booms that were detected by ordinary people thousands of kilometers away, in places that had no idea a volcano had even erupted until the sound and the pressure wave rolled through. That is the ceiling of what a shallow submarine eruption in this general part of the Pacific has already proven itself capable of, within living memory, within the same decade some of you are watching this video in. This next part matters. Just a few months ago, earlier in 2026, a magnitude 7. 5 earthquakes struck near Tonga itself, the largest earthquake recorded anywhere on Earth so far this year. That quake triggered light to moderate shaking across Tonga and forced authorities to issue an active tsunami warning for residents. It is a reminder that this entire stretch of the southwestern Pacific, from Tonga all the way across to Papua New Guinea and the Bismarck Sea, sits on some of the most seismically restless crust on the planet. According to tracking data compiled so far in 2026, the world has already recorded 50 earthquakes of magnitude 6 or higher, and 5 of magnitude 7 or higher. The strongest of the entire year remains that Tonga quake. This is not a quiet year for the Ring of Fire, and the Bismarck Sea is now very much part of that story. And now, tonight, that changes the timeline for how closely this needs to be watched. An earthquake of magnitude 6. 4 is not a small event anywhere on Earth. It is the kind of magnitude capable of damaging poorly reinforced buildings, triggering landslides on steep coastal terrain, and knocking out underwater communication cables, the same fragile fiber lines that carry internet and phone service to entire island nations across the Pacific. Papua New Guinea, like many of its island neighbors, depends on a small number of undersea cables for connectivity. A seafloor that is actively shifting from both tectonic stress and volcanic inflation is exactly the kind of environment where those cables become vulnerable, and a cable break in a remote stretch of ocean can take weeks to locate and repair, cutting off communities from banking, from emergency coordination, and from contact with family abroad. Most people are missing this next detail. Despite the size of the July 13th earthquake, the Pacific Tsunami Warning Center reviewed all available data and determined there is no tsunami threat from this specific event. The United States Geological Survey issued only a green alert, its lowest level, for shaking-related fatalities and economic losses. That is the official, current assessment, and it matters, because it means this earthquake by itself, right now, is not expected to send a wave crashing into any coastline. But that is not the whole story, and here is why. A green alert measures this one earthquake in isolation. It does not measure what happens if the underlying volcanic system beneath the Bismarck Sea continues to pressurize. It does not measure what happens if magma rising through Titan Ridge interacts suddenly with cold seawater in a shallow chamber, something NASA scientists have already said is a real possibility given how close this vent sits to the surface. When seawater meets rising magma in a confined space, the result can be a rapid, violent, explosive reaction, the same kind of interaction that helped drive the ferocity of the Tonga eruption in 2022. Right now, officials say there is no immediate danger. But right now is not the same as next week, and it is not the same as next month. One more thing you need to know. Submarine eruptions like this one do not just threaten the surface. They can build entirely new land. Researchers studying the Bismarck Sea eruption have said there is a real chance this activity could eventually push a brand new island above the waterline, similar to Surtsey, the volcanic island that rose off the coast of Iceland in 1963 and is still there today, still being studied by scientists more than 60 years later. Not every volcanic island survives. Some, built from loose, easily eroded material, wash away within months or a few years, according to research published in scientific reports. But if this system keeps building, keeps feeding material upward the way it has since May, the Bismarck Sea could end 2026 with a landmass that did not exist at the start of the year. But that is not the real story for the people who actually have to live through this, not just watch it from orbit. Think about what that actually means for the people who live near this region. Families in Lorengau go to sleep at night along a coastline where the seafloor itself is under active construction, where earthquakes can strike with almost no warning, and where the ocean in front of their homes has already turned green with mineral discharge from a live volcanic vent. Fishermen who have worked these waters their entire lives are now navigating around floating pumice rafts, chunks of raw volcanic rock drifting on currents that used to carry nothing but fish and driftwood. Local reporting out of Papua New Guinea in May already noted a tsunami alert issued as ash was seen rising from the sea, a moment that understandably terrified coastal communities who had never seen anything like it before. Power infrastructure in these smaller island communities is already fragile. A moderate to strong earthquake can knock out electricity for days. Roads along the coast, some barely maintained even in calm conditions, can crack, slump, or wash out entirely, if shaking combines with heavy Pacific rainfall, which this region sees constantly. None of this requires a worst-case scenario. This is simply what happens in vulnerable coastal towns when the ground and the ocean both start behaving unpredictably at the same time. Farmers further inland are not immune either. Papua New Guinea's economy leans heavily on subsistence and export agriculture, cocoa, coconut, and copra among them, much of it grown close enough to the coast that repeated shaking can damage irrigation systems, crack storage buildings, and disrupt the small ports these communities rely on to move crops to market. A single strong earthquake rarely destroys a harvest outright, but a pattern of repeated moderate quakes, the kind this region has now logged for 10 straight weeks, wears down infrastructure a little more each time. And rural communities with the fewest resources to rebuild are always the ones absorbing that slow, cumulative damage first. This is where the story becomes bigger than one earthquake or one volcano. The Bismarck Sea is wedged between the Pacific Plate, the Indo-Australian Plate, and several smaller microplates, including the South Bismarck Plate itself, all grinding against each other in one of the most tectonically crowded junctions on the planet. Papua New Guinea as a whole sits on this junction, which is exactly why the country experiences some of the highest rates of earthquake activity anywhere on Earth, year after year. Most of those earthquakes strike in deep water or sparsely populated terrain and never make international news. But when one lines up directly with an active eruption that has already been generating global scientific attention since May, it stops being a routine entry in a catalog and starts being something monitoring agencies specifically flag for closer review. Here's why this is serious on a wider scale too. The Bismarck Sea sits inside the broader Pacific Ring of Fire, the horseshoe-shaped band of fault lines and volcanoes that wraps around almost the entire Pacific Ocean and produces the overwhelming majority of the world's earthquakes and volcanic eruptions. According to the latest global earthquake tracking for July of 2026 alone, monitoring agencies have already logged 7 earthquakes of magnitude 6 or higher just this month, 84 of magnitude 5 or higher, and over 500 of magnitude 4 or higher, totaling more than 8,000 recorded seismic events worldwide in a matter of days. The estimated seismic energy released in that short window alone is equivalent to roughly 27 atomic bombs. That is not a random comparison meant to scare you. That is the actual scientific method researchers use to translate seismic energy into something a human mind can grasp, and it illustrates just how much raw power moves through the Earth's crust in an average month right now. Indonesia alone reported 8 actively erupting volcanoes in the same window, with ash advisories issued for volcanoes from the Philippines to Kamchatka to Japan. The planet's volcanic and seismic systems are not isolated from one another. They are part of the same interconnected shell of moving plates. And right now, in the middle of 2026, a lot of that shell is active at once. But here is the problem that keeps coming back to this specific spot in the Bismarck Sea. Unlike well-studied volcanic systems in Iceland, Hawaii, or Japan, this region has almost no history of close observation. Scientists have openly said they do not have consensus on which exact volcanic feature is erupting, how deep the vent originally sat, or precisely when it last showed activity before 1972. That means every single new earthquake, every new thermal signature, every new satellite pass is effectively new information for a system nobody fully understands yet. Jim Garvin, chief scientist at NASA's Goddard Space Flight Center, has pointed out that this is also an opportunity, a chance to use government and commercial satellites already in orbit to learn about a process almost never observed in real time. But an opportunity for scientists studying it from space is a very different experience for the people living within a few hundred kilometers of it by boat and by coastline. This is where it becomes dangerous in a way that is easy to overlook. Earthquakes near active volcanic systems do not need to be tsunami generating on their own to be a warning sign. What matters is the pattern. A seismic swarm in May, a confirmed eruption by May 9th. Continuous thermal activity through May and June. Multiple moderate earthquakes recorded in the wider Tonga to Papua New Guinea corridor throughout June, including a magnitude 4. 6 event on June 18th and a magnitude 4. 9 event on June 22nd. Then, in July, first a magnitude 5. 0 quake near Tonga on July 6th, another magnitude 5. 0 near Tonga on July 12th, and now this magnitude 6. 4 directly tied to the Bismarck Sea volcanic zone on July 13th. That is not a single isolated tremor. That is an escalating rhythm across an entire active corridor of the Western Pacific, playing out over 10 straight weeks. And now the focus shifts to what happens next, because that is the part nobody can answer with certainty yet. Monitoring agencies will continue tracking the Titan Ridge system for further thermal anomalies, further discoloration in the water, and further seismic swarms in the surrounding fault network. If the eruption intensifies, if seawater breaches deeper into the magma chamber, the resulting explosion could rival what the world watched happen near Tonga in January of 2022, an event that reshaped an entire understanding of how violent an underwater eruption can become in a matter of hours. If it does not intensify, this could simply continue as a slow, controlled release of pressure, the kind of eruption that eventually just fades out, leaving behind nothing more than a new patch of seafloor or, potentially, the beginnings of a new island. There's also a quieter, less dramatic possibility, and it is worth mentioning because responsible coverage of an event like this has to include it. Many submarine eruptions along back arc spreading centers, which is the specific tectonic setting Titan Ridge sits within, are effusive rather than explosive. That means magma can ooze and pile up on the seafloor over months without ever producing the kind of violent seawater-triggered blast that made Hunga Tonga so devastating. Scientists studying the system have noted that back arc volcanism tends to be less explosive than the subduction zone volcanism, responsible for the 2022 Tonga eruption. That distinction matters. It does not mean the situation is risk-free, and it does not mean the earthquake swarm should be ignored, but it does mean the most extreme outcome is not automatically the most likely one. Good monitoring exists precisely so that scientists can tell the difference between a system building towards something catastrophic and a system simply venting pressure the way it has for millions of years along ridges like this one. Still, uncertainty cuts both ways, and that is exactly why agencies are not standing down. The Pacific Tsunami Warning Center, the USGS, NASA's Earth Observatory team, and researchers at GeoMar are all continuing to track this site using a combination of seismic networks and daily satellite passes. Every new thermal anomaly detected by VIRs gets logged. Every shift in ocean color picked up by PACE gets compared against the previous week. Every earthquake in the surrounding 250-kilometer radius gets cross-referenced against the ongoing eruption timeline. This is not a situation anyone is treating casually, even while the official threat level for the public remains low for now. For people living across the wider region, from Port Moresby to Rabaul to the outer islands of the Bismarck archipelago, the practical takeaway right now is not panic. It is preparedness. Coastal communities across Papua New Guinea have lived alongside earthquakes and eruptions for generations, and local knowledge about evacuation routes, high ground and warning signs, changes in the color or behavior of the sea, unusual animal behavior, a sudden retreat of the tide remains some of the most valuable protection available, especially in areas where official alerts can take critical minutes to arrive. Disaster response agencies across the Pacific have spent the years since 2022 specifically studying how to shorten that gap. But geography and limited infrastructure still mean that in the most remote coastal villages, the first warning many people receive is the ground itself moving beneath their feet. International attention on this event has been building steadily since May, when local reporting out of Papua New Guinea first documented a tsunami alert issued as ash was seen rising from the open sea, a moment that spread quickly through regional social media before the international science press caught up with satellite confirmation days later. That pattern, local observation first, official confirmation after, is common in remote ocean regions where monitoring infrastructure is thinner than it is along heavily populated coastlines like Japan or the western United States. It is part of why NASA scientists have specifically framed this eruption as a test case for how well commercial and government satellites already in orbit can fill monitoring gaps in places where ground-based instruments are sparse. What happened next after the Tonga eruption in 2022 changed everything about how seriously agencies now treat underwater volcanic activity near populated coastlines. Before that eruption, few outside the volcanology community understood how quickly a submarine event could generate a transoceanic tsunami and a global atmospheric shockwave at the same time. After it, tsunami centers across the Pacific updated their monitoring thresholds and their public alert protocols, specifically because of what Tonga demonstrated was possible. That is the exact same monitoring network now watching Papua New Guinea and the Bismarck Sea in real time. For now, the message from officials is measured, not panicked. No tsunami warning is currently in effect for the July 13th earthquake. The USGS alert level remains green, but green does not mean forgotten, and it does not mean the story is over. It means the agencies best equipped to track this are still watching, still gathering satellite passes, still logging every aftershock, because an active submarine volcano sitting directly beneath one of the most seismically busy corridors on Earth is not something anyone in this field is willing to look away from. If you live anywhere near this coastline, in Manus, in New Ireland, in West New Britain, or across the water in the Solomon Islands or Northern Australia, this is the moment to know where your nearest official alert channel is, whether that is the Pacific Tsunami Warning Center, your National Disaster Office, or local emergency broadcasts. Not because a wave is coming tonight, officials say it is not, but because the system driving all of this, the swarm of earthquakes, the erupting ridge, the shifting seafloor, has already proven over 10 straight weeks that it does not stay quiet for long. Zoom out even further, and this single quake becomes one data point inside a global pattern that has defined 2026 so far. This year has already produced a magnitude 7, 5 earthquake near Tonga, the strongest anywhere on the planet in 12 months, alongside dozens of magnitude 6 events scattered from the Solomon Islands to Afghanistan, where a magnitude 5. 8 quake earlier this year became the deadliest of the year, killing a dozen people. 50 earthquakes of magnitude 6 or higher, 5 of magnitude 7 or higher, and thousands of smaller tremors have already been logged worldwide. None of that guarantees what comes next in the Bismarck Sea specifically. Earthquakes and eruptions do not work on a fixed schedule, and no scientist tracking the system is claiming they can predict the next move with certainty. But it does mean the backdrop against which this eruption is unfolding is an unusually active one, and it is part of why agencies that track seismic and volcanic hazards worldwide are treating this particular stretch of ocean as a genuine point of interest rather than background noise. The next several days will matter more than most people realize. Satellites will keep passing overhead, seismometers will keep logging every tremor along this stretch of the Ring of Fire, and somewhere beneath the waves of the Bismarck Sea, a volcano that spent over 50 years completely forgotten is still pushing material upward, still building towards something nobody can predict with full certainty yet. This system is still evolving tonight. We will know more soon, but right now, this is a story worth watching closely because the ocean floor beneath one of the most crowded volcanic corridors on the planet is still moving.